Hello friends, welcome you to the Beautiful Mind classes. Today's topic is real sequences, which is a part of real analysis. So the first thing that comes in our mind is what is real sequence? What is basically sequence? So sequence is basically is order. Sequence is defined by some order. Where there is some ordering, that is called sequence. So in first line, what is real sequence? So real sequence is sequence of real numbers. So that is basically a function. All we know about the function. So sequence in first line, sequence is a function. Function f from set of natural numbers to set of real, whose domain is set of natural numbers and range is set of real numbers. For example, f of n is equal to n. F of n is equal to 1 by n. F of n is equal to minus 1 raised 4. Okay, so here we have three examples of sequences, real sequences generating sequence of real numbers for all n belongs to set of natural numbers, for all n belongs to set of natural numbers, for all n belongs to set of. So here our input is set of natural numbers. So what kind of sequences it generates? So it will generate 1 square, 2 square, 3 square, 4 square, sequence of real numbers. It will generate 1 by n, sorry, 1, 1 by 1, 1 by 2, 1 by 3, 1 by 4, like this will generate minus 1, plus 1, minus 1, plus 1, minus 1, plus 1 and 2. So here basically I have taken these examples with some objective or my objective is to identify the type of sequences. Basically with the help of these examples I have taken three types of sequences. One is we can observe that the sequence is increasing order. This sequence is in decreasing nature and this sequence is one time minus 1, other time plus 1, minus 1, plus 1, minus 1, plus 1. So here we can observe that from these examples sequence are of three types. Basically one is monotonically increasing sequence. Sequence, decreasing sequence, and also have oscillatory behavior. Sequence having oscillatory. That means for one value this is taking minus 1, for next value of natural number this is taking plus 1, minus 1, plus 1, minus 1, plus 1. It is having oscillatory nature. And we have another sequence like fn is equal to minus 1 raised for n into n, for n belongs to set of natural number. This sequence is having oscillatory nature, but this is having infinite oscillation. We can see here this is minus 1, plus 2, minus 3, plus 4, minus 5, plus 6 and so on. So here all types of sequences we can see in the examples. One is this is called divergent sequence, diverging nature, monotonically increasing but unbounded. This is having no bounded, no bound, because 4 square, 5 square, 6 square. So as the input is growing, the sequence is growing. The value of the sequence is growing. In this second example, we have as the input is growing, the value of the sequence, value of the term is decreasing. So this is monotonically decreasing sequence. This is in the third one. this is oscillatory. This sequence is having oscillatory behavior, but having only finite oscillation, -1, +1, -1, +1. And the fourth one is the sequence is having oscillatory behavior, but is having infinite oscillation. As we are going in the higher terms, towards the higher terms, the sequence is having higher and higher values in negative as well as positive values, -5, +6, -7, +8, and so on. So, observing these examples, we have four types of sequences. One is diverging nature sequence, another is converging nature sequence, and sequence is having finite oscillation and infinite oscillation. So here we can see that in the higher terms, higher and higher terms, sequence value of the term is going very large, and in the second sequence we are looking that the value of the term is decreasing, and when the input value is very high, very large, the output, that is the value of the term, it will be near to 0, and as n approaches to 0, the value of the term is near to 0 as well as in the first term we are looking that the value of the term as tends to infinity, value of the term will also tend to infinity. Okay, so these are the types of sequences basically. So कौन से sequence के type है? One is divergent sequence, second is convergent sequence, and third is oscillatory. In this having finite and now we have bounded sequence that are very useful. Bounded sequence, because in most of the cases where the application is seen, bounded sequence is very important. So bounded sequence, so if there exists two real numbers ये कुछ भी हो सकते हैं like -k and +k, such that each term of sequence fn will lie between +k and -k for all n belongs to set of natural number, then we say that the sequence is bounded. That is an upper bound and lower bound. That is every term of sequence. When every term of sequence lying between two finite real numbers small k and capital K, the sequence is bounded sequence. For example, fn is equal to 1 by n for n belongs to set of natural number. In this sequence, fn is lying between 0 and 1. Each term of the sequence is lying between 0 and 1 for all n belongs to set of natural number. Hence, this sequence is bounded sequence. But when fn is equal to n square for all n belongs to set of natural number, fn is greater than or is equal to 1, but there is no upper bound. There is no upper bound. There is no real number in this case by which every term of the sequence is less than, hence this sequence is not bounded. This sequence is bounded below but not bounded from the right hand side on the real line. Okay, so bounded sequence क्या होते हैं? So bounded sequence for which we can find two real numbers small k and capital K, such that every term of the sequence lying between these two real numbers. So we have very important example, because this is very important sequence, as we can see in the next classes. Now another definition of bounded sequence, so that is given by range of sequence. Range of sequence. So range of sequence is, this is the set of distinct terms of a sequence. Okay, so set of distinct terms of sequence is called range of a sequence. So a sequence is bounded if the range of the sequence is bounded. For example, if we think about the range of this sequence, fn is equal to 1 by n. So range of this sequence, fn, when fn is equal to 1 by n is given by 1, 1 by 2, 1 by 3, 1 by 4, so on. And this is a bounded set, bounded above by 1 and below by 0. We can never find the number 0, hence this is on the, from the right hand side this sequence is bounded by 1, and from the left hand side this sequence is bounded by 0. All the terms of this sequence is lying between 0 and 1, hence this sequence is bounded. Guys, today's class is up to the bounded sequence, and next topics in the real sequences we will cover in the next class.